There is a lot of confusion over what the Heisenberg Uncertainty Principle means and how it can be applied to our life at large. The first thing we need to clear up is what exactly uncertainty means. We like to think of physical objects using the particle model, which assumes that the absolute location of an object can be known if one looks hard enough. However, we now know that if we look hard enough, the idea of a precise location breaks down because nothing is truly in one specific place. Instead, everything exists in a range of places, a distribution known as a wave packet. The height of the wave at any given point corresponds to how likely you are to detect the object at that point. But be warned, that does not mean the object is just at that point. Instead, it is kinda at that point, kinda at this point, and more at this point than at the others. We can describe this uncertainty of position with a number we'll call delta x, which is the average distance from center you will detect the particle. This number, delta x, roughly corresponds to how wide the wave packet is. Just like position, momentum also gets a little fuzzy when you look close enough. You can also describe momentum as a wave packet, except where the x-axis used to correspond to position, it now corresponds to the likely momenta you will detect the particle with. Like position had delta x, momentum has delta p, corresponding to the width of the momentum wave packet. All the Heisenberg Uncertainty Principle states is that when we multiply the fuzziness of position, delta x, with the fuzziness of momentum, delta p, it must be greater than or equal to the value h over 4 pi, where h is a number known as Planck's constant, a number which often pops up in quantum mechanics. In other words, if I have a tighter range of positions, I must have a looser range of momenta. And if I have a loose, wide position wave packet, I am allowed to have a tighter, smaller momentum wave packet. To see this principle in action, I will show why we can never have a perfect, tight laser beam that stays a tiny dot forever. The opening at the end of a laser restricts where light can come from, creating a position restriction, a delta x. According to the Heisenberg Uncertainty Principle, this means that whether we like it or not, there must also be a range of sideways momenta, defined by delta p, even though we only want the light to go straight. Because the light must necessarily have this range of sideways momenta, the light will skew to the sides, and the tiny dot we started with at the opening of the laser will eventually grow. Interestingly, if we try to counter this spreading by making the hole on the laser smaller, the intuitive solution, we are actually increasing the uncertainty in momentum. This means that the laser will actually be less focused if we make the outer hole smaller. Weird.